Welcome everyone to the US Web Design System monthly call for September of 2024. It is getting a bit cooler out here in the Pacific Northwest. This month we are celebrating the fall equinox this weekend with a USWDS logo in green, white, and blue, like the Earth. And also, at least around here, I am seeing more and more pumpkins around town, both on stoops and in stores. So here is a pumpkin-colored USWDS logo. Slide 2. My name is Dan Williams, he, him, and I'm the USWDS project lead. And here's my on-screen avatar, dark hair, blue sweater, collared shirt, and now with glasses, matching real life me, who is wearing a blue shirt today, green socks, and red slacks, approximately red 60. As Jeannie mentioned, we are recording this call, and I'm happy to say we've started to be able to share the recordings of these monthly calls publicly. You can find pretty much everything from the last year's worth of monthly calls, month and a year and a half now, back to January 2023 on our website at designsystem.digital.gov/about/monthly-calls. We typically post videos shortly after the monthly call, and we also link out to the slides and the script hosted at Digitalgov. We've also started collecting each month's Q&A as a GitHub discussion linked from the monthly calls page. And we've posted a link to our monthly calls page in the chat. We'll be posting links and other references into the chat as we go along. And today, we're trying something new when it comes to chats and questions. Today, in your Zoom window, you'll find a Q&A button in addition to a chat button, possibly hidden under a More button. But there should be something down there where you can find that says Q&A. So we'd like to encourage folks to ask questions in the Q&A section instead of in the chat. So you can take a sec now to find that Q&A section and open it up. If any member of our team can answer your question in the Q&A section, we'll do so. Otherwise, there'll still be some time for questions and answers at the end of the hour. But the chat is still nice and important too. So we can use the chat for introducing ourselves or for any other comments or discussion. But if you have a question, something you'd like us to answer, either later or now, ask it in the Q&A, and we'll try to use that to organize our answers. And be sure to introduce yourself in the chat. It's nice to know who's here, and it's good to have you here today. Hopefully the chat Q&A thing won't be too confusing. We'll see how it goes. For those of you who find chat Q&A distracting, you're welcome to close or hide those discussions during the main presentation. You can reopen them later during the Q&A session at the end of this call. So thank you. And with that, let's get started. Slide 3. So what's our agenda for today? Well, we've got a number of things to show off. We've got a couple new sites to feature and some quick product updates. And then we'll talk about what we're seeing, learning, and thinking about the web components landscape. And then we'll have some time for a bit of Q&A. So slide 4, let's get into it with today's featured sites. A couple great examples today. Slide 5. First, pbgc.gov, a USWDS-powered website for the Pension Benefit Guaranty Corporation. Since 1974, PBGC has protected retirement security and the retirement incomes of over 31 million American workers, retirees, and their families in private sector defined benefit pension plans. The PBGC homepage features an, I would say, immediately recognizable USWDS-themed header and navigation in red, white, and blue. And the hero image is a complex texture of charts and graphs with the words FY 2023 Projections Report. Slide 6. And also, a bit closer to home, tts.gsa.gov, a new website for the Technology Transformation Services here at GSA. TTS applies modern methodologies and technologies to improve the lives of the public and public servants. They help agencies make their services more accessible, efficient, and effective with modern applications, platforms, processes, personnel, and software solutions. The TTS homepage shows a gray-blue hero section with an illustration of a diverse range of people using devices. The text reads, "Every interaction with the public is an opportunity to improve trust in government." Slide 7. So congratulations. Great work. Be sure to let our team know when a new site launches, either with an email or a note on the USWDS public Slack channel. Slide 8. So now for a few product updates. Slide 9. We were hoping to get USWDS 3.9.0 out last month. It just didn't happen. Got a lot of discussions, conversations, things we were working on in there. It's moving right along. I feel very confident that it's on track for the end of this month. Probably next week, we'll see. Slide 10, as a reminder, here's some of what's coming in USWDS 3.9.0. We're fixing a tab order bug in the mobile header, fixing a keyboard mouse interaction issue in the date picker, improving the performance of input mask, improving the legibility of pagination links, adding the ability to add custom breakpoints to utilities. So good stuff in there, moving right along, slower than I was hoping, but coming up soon. Slide 11. We're also continuing progress on publishing accessibility test pages. Moving right along with those. We've got 3 new ones up on the site right now: checkbox, radio button, and combo box. We're posting links to these new pages in the chat, and we're working on a bunch of new component pages for next month. Breadcrumb, pagination, side navigation, and in-page navigation. So stay tuned for those. Slide 12. Next, it's been a bit over 5 years since we released USWDS 2.0, and it's finally time to sunset the version 1 documentation site. We've been keeping it around sort of as an archive for the last couple of years, but it's not really possible for us to keep it up in perpetuity, preserved in amber, especially while all across government teams are pushed to be extra intentional about the number of active websites they maintain. So we've targeted the end of this year, 2024, as a decommissioning date. So say your goodbyes to the V1 website. That was v1.designsystem.digital.gov. And reach out at our email address, uswds@gsa.gov, if your team currently uses any aspect of the 1.0 site in your day-to-day work. We do see traffic there, but we're often not even sure if traffic to that site is a mistake and whether it should be coming to our primary site instead. So if you use any aspect of that site in your day-to-day work, we can try to determine if there's anything we should keep before this site is only available via a resource like archive.org. Slide 13. So, and finally, checking in on our public discussions. There's a new one since last month's call, which is a proposal for info or follow as a sidebar or a portion of the footer, along with a new pattern proposal. We should note that we're still working out the process for patterns to figure out how that should be different from component proposals. The pattern proposal is for pre-filled information in a form. We also have an accessibility discussion about how you're all using the range slider. And lastly, we also have a summary of the questions and answers from the August monthly call. Slide 14. So now let's get into our main topic, the web components landscape. I know you have questions about our approach to web components, and we do too. Lots of questions. As we start to make the big leap out of our legacy code base and into the next generation of the design system, we want to take the time to understand the landscape of web components, how they're documented and used, primarily in design systems, but not exclusively. From this landscape analysis, we can begin to identify not only trends and patterns, but aspects of implementations that we identify as particularly effective or notable. And from that data, we can begin to create a mental map of the problem space, one that will help us chart our own way through. And one note is that we will be mentioning some product names here and there as we talk about this. These are for reference only and are in no way an endorsement of the site or service. So to help talk about what we found and what we find notable, I'd like to introduce a couple members of our team. Slide 15. First, Matt Henry, the engineering lead on the USWDS team. Matt, can you introduce yourself and give a quick self-description for anyone audio only?
Sure thing. Hey, y'all. Matt Henry. I'm based in Raleigh, North Carolina, where the sun is finally coming out after a gloomy, rainy morning. I use he, him pronouns. And yeah, as Dan said, I'm the engineering lead for the design system. I'm a white man with glasses, close cropped beard, and I'm bald, wearing, unfortunately, I think the same red and gray shirt that I wore on the last monthly call. So I'm going to have to remember to fix that for the next one. So this isn't just my monthly call shirt. But that's it for me.
Thanks, Matt. Yeah, don't change. I'm getting used to it. Slide 16, I'd also like to introduce Jacline Contrino, our UX researcher and a contractor on the USWDS team. Jacline, can you introduce yourself and give a quick self-description?
Sure. Hi, everyone. I'm Jacline. I use she, her pronouns. And today I'm wearing a pink and white striped button-up shirt and big gold hoop earrings. And yeah, I have like shoulder length brown curly hair. And yeah, that's about it.
Thank you, Jacline. So why don't you take it from here and talk about what we've been doing?
Happy to. So slide 17. So wouldn't you know that web components are a pretty big topic, and we have a lot of questions and things that we want to learn about them. Slide 18. So for instance, how do we keep government teams in mind with what we're building? What kind of team structures, tech stacks, and resources are you all working with? What does good documentation look like? And what are the key things we need to get right? What are some of the key ways that web components are structured? So how does data and content get into a web component? What models do they follow? How flexible can they be? And how are they distributed and installed? And performance, how fast do they need to load? How much code do they require? How are teams developing web components that are resilient and stand up to stress? Slide 19. So those are just a few of our questions. And since it's nearly impossible to answer all of them with a single research approach, we're using several methods, such as the landscape analysis, as mentioned. We're doing that for design systems that offer web components. So what are other design systems doing, and what might we want to adopt? A survey to gauge government team size, staffing, tech stacks used, familiarity with certain programming languages, and more. Discussions with teams that are already building with web components. We're doing one-on-one interviews for more in-depth and technical conversations with experts to learn about their experiences and lessons learned. And finally, the beta program itself and the feedback and issues you provide. So we're nearly done with the landscape analysis and have completed the survey. We've started interviewing folks individually, and we'll continue to do that for the next few weeks. Slide 20. So let's talk about what we found with our government teams and tools survey. So we sent out a survey last month to gauge team structures, resources, and technology of government digital or product teams. Slide 21. So first of all, thanks to all of you who have filled that out. We got a great response. And it's really important to us that we understand your teams and how you work. So we were really delighted that so many of you filled it out. We had a total of 115 responses, and over 50 different agencies were represented in the survey, which was fantastic. Slide 22. So let's talk about what we found with digital product team structures first. Slide 23. So the size of teams tends to be on the small side. About half of respondents said their team had between 3 to 10 people. But surprisingly, nearly a quarter reported having larger teams of over 20 people. Most teams report having 5 or fewer developers, and the same goes for designers. Surprisingly, about 1 in 5 respondents say they don't have a developer on their team. Slide 24. But even so, when we looked at all the roles people reported having on their digital or product teams, developers were the most represented, followed by designers, UX researchers, content strategists, and product leads, respectively. Slide 25. So generally, the feeling among respondents is that their team is not fully staffed and that people are fulfilling multiple roles on their teams. About 57% do not think that their team is fully staffed, and about 25% do. A vast majority of respondents, or 87%, said that people have to fulfill multiple roles on their teams. So some teams might both feel fully staffed and require folks to accomplish the tasks of multiple roles. Slide 26. Another question we asked was, does your team or agency have its own design system? And we were pretty excited to see that of those who answered this question, which was about 82 people, a majority of them, 70%, said that they use a design system in some way. So many of them have already developed or are currently developing their own design system, often extended from USWDS. Others reported that they only use USWDS and don't have their own design system. Slide 27. So what did we learn when it comes to tech stacks and skills of teams? Slide 28. We asked about teams' familiarity with certain coding languages, GitHub, and web components. We learned that teams are most familiar with HTML. That holds true for CSS and JavaScript as well, although familiarity with those technologies was a little less than HTML, particularly JavaScript. Most reported being familiar with GitHub, and a large proportion are somewhat familiar rather than very familiar with web components. So comparatively less than the other technologies. As for the most used technologies, folks reported that React and Angular are their most used frameworks. Again, HTML, CSS, and JavaScript were the most used programming languages. And NPM, Yarn, and CDNs are the most common package managers and distribution systems that teams use. Slide 29. So given these findings, we do have some takeaways as we develop web components. Slide 30. We know that we need to make USWDS easy to adopt for small teams that are understaffed and have few or no developers. For instance, installation and setup should be as simple as possible, and our documentation should be clear, explicit, and not make too many assumptions about technical familiarity. This would also benefit those who said they're not very familiar with web components. And since many of you reported that you often fulfill multiple roles on your team, we should, again, be careful not to make assumptions. We should focus on what people are trying to do rather than who does it, since many might be doing the job of a developer and a designer. And finally, now that we know a bit more about the tech stacks used on many government teams, we can better keep those in mind as we develop web components to ensure easier, seamless integrations. Slide 31. So now let's take a look at the web component landscape analysis that we're starting to wrap up. Slide 32. Let's start by sharing our research questions. Slide 33. So we were interested in a few specific categories. Documentation. So what are other design systems prioritizing in terms of web component documentation? What types of content do we see? Code structure. How are other design systems building web components? What's their component model? How does content and data get into them? In general, from a developer's perspective, what does a component look like? Code size and performance. So how big are these things? Like how much data does a browser have to load before the component loads? Is there any commonality around a component's footprint when comparing similar components? And distribution. So how are these components getting from the design system to the project using it? How are they loaded onto a page? How straightforward is it to add a component to a project? Slide 34. So we're approaching this landscape analysis in a really collaborative way, since there's a lot of subject matter expertise required to collect and understand this information. Our 3 senior developers have been working with me, and we're also working very closely with our product lead, Dan, and engineering lead, Matt, on the Fed side. Slide 35. We drew from about a dozen different design systems for our analysis, from inside and outside the government space, both in the United States and elsewhere. This includes government design systems from VA, CMS, and the state of California, as well as common non-government web component-based systems like Carbon, Nord, Patternfly, and Shoelace. So far, we've collected data on a few specific components common to most design systems: link, card, accordion, and alert. Individual core team developers are collecting data across design systems to update our landscape spreadsheet. We've had several whiteboard sessions to identify trends and findings, and this helps us build a common understanding and familiarity with the types of decisions that design systems are making. And we can refine our own questions and often uncover some new ones. So this effort is still ongoing, but here's what we've learned so far, starting with documentation. So slide 36. Documentation is at the center of the experience, and it's often the first opportunity to interface with the product. And we've seen that design systems have their own priorities and approaches. Slide 37. Essentially, documentation helps you do what you need to do. Like what were we trying to do? Well, we were looking at a few things, a few tasks. So getting familiar with a component, or kicking the tires, as it were. Understanding how to work with a component as directly as possible. We looked at installing a component into a project. So how do you get it and use it? And we also looked at configuring and customizing a component. So how can you make a component do what you need it to do? Either changing what it does or changing how it looks. Slide 38. Let's talk about the ways documentation can help users get familiar with a component. The most common way that systems try to build familiarity is with interactive demos. So giving developers the opportunity to manipulate a component and see how it behaves, often when still in the context of documentation. This was ubiquitous in non-government design systems and common, if not consistently so, but common in government design systems as well. A couple of design systems build most interactivity directly in their docs pages, but most design systems direct users to external platforms such as Storybook, CodePen, or Code Sandbox to allow this kind of interactivity and basic prototyping, like what you see on this slide. An example of Storybook documentation that allows a developer to manipulate properties and text content. But it wasn't always clear when there was interactive functionality available. This link was sometimes buried in the docs. Without some kind of interactive functionality, developers have to rely only on API documentation to understand what a component can do, and increasingly the ubiquity of interactive documentation outside of government indicates that developers will increasingly expect the ability to interact with the component before they install it into their project. So we see interactivity as critical to the developer experience. Slide 39. How do you install a component into your project? Well, finding documentation that answers this question was a bit of a challenge for us. It was rarely clear from a components page how you would install the component into your project. Only a handful of design systems had an installation section in the component documentation. On this slide, we see an example from the California design system, which shows how to install the component through either NPM or via a CDN. It's possible that for many design systems, installation is baked into some other aspect of the product, but it was surprising to find that so few of them provided installation instructions from the component package. USWDS is perhaps distinct in our expectation that teams will use our web components a la carte, that is, individually and selectively. So this may have influenced our expectations. But we see value in making this information clear and prominent. Slide 40. So once someone installs a web component package, they'll need to connect the component to their application's data, content, and logic, and configure the component to do both do what it needs to do and display how it needs to display. So this is the core responsibility of any component in an application. Establishing and maintaining this connection and configuration is perhaps a developer's most important task. So we took a note of how other design systems are documenting their web component connection and configuration options, otherwise known as the Application Programming Interface, or API. Slide 41. When it comes to documenting an API, there are a number of common ways of interacting with components reflected in the documentation. So first, properties. These are settings passed to component markup. For example, an alert component may have a variant property that can be set to something like warning, info, or error, depending on the type of alert. This property usually changes the color of the alert and its icon. Events. Data a component sends based on a component interaction. So for example, an input component may have a blur event that the component emits or fires when a user navigates away from the input and it loses focus. Thus, blur. Slots. So these are named content regions inside a component. For example, a card component might have a slot named footer, where you'd add the content that belongs at the bottom of the card. Then parts. So these are subsections of a component, stylable with CSS. For example, an accordion component might have a part for an individual item's open-close indicator. And tokens. So tokens are CSS variables that influence component styling. For example, a card border radius CSS variable might set the border radius for all application cards. Pretty much every component has properties of some sort, and we see property documentation in any web components-based design system. The rest of the elements of an API can vary from system to system and component to component. Less common elements of an API, but still potentially useful, include methods, which are JavaScript-specific controls for component interactivity, and content model, which is a way to group properties that accept content together. Slide 42. We found that overall, Web Component API shared some structural commonalities. So APIs are consistently organized using the categories we looked at in the previous slide. The API almost always appears on the same page as other component information, though it can occasionally appear in a page level tab. API documentation is consistently organized using tables showing the names of the API items, the type of data they accept, and their default value. And all of this tends to be more understandable when it's tied either to some kind of example or to an interactive component where you can try out the setting in the component. Slide 43. As we mentioned earlier, we can't expect that everyone shares the same level of expertise, especially around web components. We identified some real usefulness in providing links to contextual information about API categories, like this example of a link that invites users to learn more about using slots next to the component slots documentation. Slide 44. But looking through the components and the documentation together, we sometimes would see places where there seemed to be undocumented functionality, particularly related to undocumented CSS parts. And design tokens didn't yet feel well integrated. Either they were completely omitted or there were so many of them documented that they were hard to browse and understand. It was like a real wall of text and code. But design token documentation in general, while it's potentially of use to designers, was one of the most designer unfriendly parts of the documentation, which leads us to wonder, like, is there a type of documentation only for developers? And perhaps that's okay. Maybe the appropriate place for designer-friendly documentation is in the tools designers are already using, so in design kits and designer-focused software. Slide 45. Another thing we looked at was how other design systems are documenting multiple frameworks or component flavors, so to speak. So in other words, how do they document components available in multiple formats, like a component available as plain HTML, web components, and also as React? We will be in this situation as we move to web components, supporting both the new generation of the design system and the existing legacy version we use today. Slide 46. Design systems tend to approach distinguishing formats and documenting formats differently. Some use tabs to display documentation for different versions on the same page. Some split formats into different pages. Some handle different formats on different platforms, like Storybook, or completely different websites. At times, it was unclear if web components even existed in some of the design systems, and it took some digging to figure it out. So distinguishing and documenting both legacy USWDS and web components USWDS will be a challenge. We know that supporting interactivity is pushing us in the direction of Storybook documentation for the near term, but we'll have to work extra hard to make it clear to users that, what documentation lives where. Slide 47. And lastly, we looked at how design systems communicate component status. So for example, how do design systems help users answer questions like, should I use this component? Like, how mature is it? Is it passing the required checks? Slide 48. So we looked at how design systems are documenting accessibility status of components. We found that while most do not provide this information at all, a handful of them did, mostly with the use of tags. So we really liked one design system that used testing tags for different component states and test types, as you can see on the screenshot on the slide. So they offer, tags for testing types like keyboard navigation test status, for instance. Slide 49. And when it comes to indicating component maturity, such as if the component is in an experimental phase, a stable phase, deprecated, etc. Again, many design systems use clear and simple tags to communicate that. Although we did find one that used a type of like step indicator to show the component's progress through a multi-step process, as we're showing in this screenshot for this page alert. It has kind of these different development stages, and the alpha is highlighted there. So tags are usually at the top of the page, but they also occasionally show up in the side navigation, and sometimes icons are used as well. Some tag labels we saw were things like in research, alpha, beta, production, planned, draft, new, ready, stable, experimental, etc. So also some of them indicate a version number with tags as well. So across design systems, status tags serve as kind of like a mini set of dashboard lights for a component. Users are likely growing accustomed to finding indicators at the top of a component's page that give an at-a-glance confirmation that a component is okay to use and conforms to requirements.
So this is Dan. Documentation is a huge subject. And while there are lots of ways to approach guidance across design systems, we've identified a few key common, almost like user stories related to technical guidance for components. So we need to support at-a-glance confirmation that a component is okay to use. An obvious location for web components documentation connected to our existing documentation. The ability to interact with the component before installing it into a project. Succinct component level installation instructions. Clear and logical API guidance alongside an interactive component. And a documentation-driven approach that keeps documentation current with functionality. So those are my big takeaways. Back to you, Jacline.
Thanks, Dan. So beyond documentation, we wanted to learn how design systems are distributing web components. Slide 52. The quick answer is that most design systems offer distribution through an NPM package or directly through a CDN link. One design system offered a direct download of a zip file, but as we mentioned earlier, it wasn't always easy to find the installation instructions, and it wasn't always clear if teams were able to install only specific components. Matt, what are our preliminary thoughts on distribution?
Thanks, Jacline. We'll most likely offer a couple of ways that users can add USWDS web components to their sites and applications. First, we'll definitely have an NPM package. Since there's a package for the current version of USWDS, many teams will already be familiar with this way of getting our code into their projects. The USWDS Web Components NPM package will have pre-built but unoptimized versions of the components to allow you not just to add them, but also to extend and modify them. And when I say components are pre-built, I mean that we'll run the component source code through our build tool, a tool called Vite, to bundle all the dependencies together and compile any styles that need pre-processing. Pre-building in this way is how we're moving past the need for a separate package like USWDS compile for building USWDS web components. If you install the components from NPM, this is what you'll get. Alternatively, we also see value in distributing the components via a content delivery network, or CDN. CDNs are third-party platforms that are optimized for fast distribution of assets like code directly to the end user's browser. Adding the CDN version of the web components to a project should be as simple as adding a script tag to the page pointing to the CDN's URL. You'll be able to immediately start working with the components on any page that includes that script tag that points to the CDN link. We expect that different installation methods will work better for different teams depending on their needs. CDNs can be helpful for teams that don't want or need to do their own optimization of components and just want to easily add them to their sites or applications without the complexity of the build process. Alternatively, packages are great for teams that want to interact more directly with the code inside of components or who have their own build pipelines where they'll integrate USWDS web components. Now over to Dan to talk about component structure.
All right, thanks, Matt. Slide 54. So one of the gnarliest items we're starting to get into in our landscape analysis is component structure. How do components express what we might think of as their component model? And perhaps the best way to explain what I'm talking about here is to look at an example. Slide 55. So way back a million years ago in April, we gave an introduction to web components, which included this slide that outlined a potential model for a breadcrumb web component. The general idea with component modeling is that with web components, we're able to simplify our component in a way that's often impossible with conventional markup that uses only classed elements for structure and presentation. We can reduce it to only the model of a breadcrumb. The breadcrumb in this slide reduces the 54 plus lines of conventional markup into 6 lines of web component markup by simplifying a breadcrumb into a collection of links, those ahrefs in there under USA breadcrumb. USA breadcrumb is the web component, and inside of that is the content of that component. So under the hood, the web component uses JavaScript to manipulate that simplified markup into the markup required to render the complete breadcrumb in the browser. Slide 56. We could call this particular modeling technique simplified HTML web component, like structured content with a simplified form, since it uses simplified native HTML as the core of the model and wraps it in a web component wrapper. That list of A's there surrounded by a USA breadcrumb. Slide 57. Another modeling technique might take a similar approach, but provide a more semantically complete HTML core. We could call this a standard HTML web component, structured content with a complete semantic form. You might think of these HTML-based models as like a progressive enhancement approach to web components, using the building blocks of native HTML, but using the web component custom element to style, enhance, and provide an interface layer to the JavaScript frameworks. Slide 58. But you could go further and abstract away native HTML altogether. Perhaps systems can build a more straightforward model by leaving native HTML behind. Instead of those anchor links, those A links, this model uses a custom subcomponent instead, the USA BC link. I didn't spell out breadcrumb because it was too long for the slide. We could call this a modularized web component, structured content abstracted with custom elements. This can be useful if the component has a structure that doesn't translate obviously and directly into native HTML. Subcomponents can help modularize a component and sometimes give teams options for rearranging component internals. Slide 59. And at the farthest end of the abstraction spectrum is a web component with really no content at all. There's nothing inside those 2 USA breadcrumbs. We could call this a self-contained web component with content fully abstracted as properties. Here we see an example of a self-contained breadcrumb where the links are expressed as a JSON object, converted into a string and passed into a links attribute. And so this is the lens we've started to use to understand the landscape of design system approaches to component structure. An advantage of a structure like this is that nobody has to know what the structure of the inside of the web component is. It's a complete black box, which leaves everything up to the web component, which can be useful because maybe designers don't want to, or developers don't want to think about that at all. Slide 60. So what can we learn about how systems represent the parts of a component? Slide 61. Across the landscape, is content content or is it data? Slide 62. And do design systems mostly use native elements or mostly custom elements in their internal structure? Slide 63. We started by looking at the accordion component and the alert component, and a little bit with card, but the results are kind of inconclusive. But with only the exception of one design system's accordion component, we don't see many examples of passing elements other than paragraph elements, P tags, into web component content. The biggest consistency we can identify so far with design systems seems to be that these systems will be inclined to build self-contained components, unless those components need to parse rich text or text that's less structured. Accordions are more likely to have their primary content as content, the primary content as content, and heading content as data. Alerts are something of a mix between content as data and as content. Alerts tend to be too simple to warrant modularization and subcomponents, but accordions we see across the landscape are often using subcomponents if that component accepts heading as content and not as data. There'll be a subcomponent for heading. There'll be a subcomponent for the content of the accordion. Slide 64. But we've also expanded the scope when it comes to web component structure, since it's really an active topic of conversation with a lot of interest and opinions from developers inside and outside of design systems. So Matt, can you talk about why that's so?
Thanks, Dan. Yes, the active discussions around web components these days are often centered around performance and, as you alluded earlier, progressive enhancement. One thing that almost all the design systems we looked at have in common is that the components more or less require JavaScript to render content. As we saw, you can use these components a lot like you might use a self-contained React component where the tag itself is empty or has very minimal content inside. Slide 66. In the landscape analysis, we didn't see many custom element-based design systems using the HTML web components model. The California Design Systems accordion component, which contains a set of native HTML details and summary elements, is probably the best example. However, this approach is gaining a lot of momentum with developers who focus on performance and accessibility. Because HTML is what all browsers understand by default, when a component is written this way, the content inside renders, whether or not JavaScript runs, or whether or not it runs promptly. If and when JavaScript executes, it will apply the component's custom look and feel, the styles and enhancements, but if it doesn't, the user can still see the content and interact with the browser native controls. Slide 67. HTML remains the future-proof foundation of the web. When you can't always predict the context in which code is going to run, and when we think about potential edge cases at scale, especially with the availability needs of government products and services, it makes sense to consider the resilience of HTML, the importance of critical content, and the continued relevance of a progressive enhancement approach. Back to you, Dan.
Thanks, Matt. So that's what we've been seeing across the landscape and elsewhere when it comes to web component structure. One last thing I'd like to quickly touch on is performance. It's one of the last things we've been able to get to in our landscape analysis, but it's something that's growing in importance. Slide 69. Like so many other things, performance is complicated. Caching, compression, application structure, hydration, and code quality all play a role. But there's still some value in tracking good old-fashioned code size. Slide 70. So here we see a selection of alert web component JavaScript across the landscape. Some of these were easy to measure since they were relatively self-contained. Others were estimates since we weren't able to directly install them in projects, and they included imports that we haven't fully mapped and measured. But I think this gives a good sense of the differences in the landscape here for an alert. With the smallest coming in at about 3K, and the rest hanging out in the general vicinity of 10 to 12K. And then there's the outlier at 367K. Maybe it was having a bad day. And to be fair, it gzips down to about 35K, but still that can take up a bit of a project's performance budget. Slide 71. Accordion didn't have this extreme outlier, but it is a heavier package in general with an average of around 30K. It's still pretty early in our performance analysis, but we want to be really considerate as we move forward, understanding the balance between functionality and weight, and trying to pick a path forward that delivers the necessary amount of configuration in the smallest possible size to be really aware of performance as we move forward. Slide 72. Almost every item we've discussed in our landscape analysis is a question of balance and priority. There are rarely clear right answers and wrong answers, rather decisions that favor one outcome over another. This landscape analysis is an important tool for us in understanding different approaches to product balance. And this landscape analysis is just another data source alongside the surveys, interviews, discussions, beta feedback, and other perspectives we hear in forums like this very monthly call. Slide 73. We're doing our best to understand what a good balance looks like for our design system and for the diverse and wide-ranging audience of folks that use our design system and the products we build with it. As we move forward, our legacy implementation of USWDS into a web components generation, we'll be using a number of principles and goals as our guide. First, our design principles. Start with real user needs, earn trust, embrace accessibility, promote continuity, and listen. And next, our mission, vision, and pole star, helping government teams align, design, and keep their websites and services up to date in the service of empowered and supported digital service teams and familiar and easy to use digital services. So together we can shape the future of government digital services. And as we shape this future of the design system, we believe there's at least one more layer of principles to explore, what we might think of as engineering principles or engineering and product principles. These answer the question, how are we designing the design system in the service of our design principles and mission? What do we really care about? What helps us make hard decisions? And what does this mean for our product? These aren't just abstract things. They influence what we do and our approach to judging the success of what we do. So next month, we'll try to tie it all together with a principles-driven approach to USWDS.